Hello, this is Mrs. Nearing, and in this video we're going to be going through the review problems for the acid-base quiz. And you can see here at the top we're covering topics from the lessons from 632 to 634. Some things we talked about were common properties of acids and bases, the relationship between pH and acidity. So, if you have a low pH, does that mean you're an acid or a base? What does that mean? Identifying substances likely to be acids based on their formula, being able to write out these equations using that Bronsted-Lowry definition, which remember that one is bases accept, acids donate. That's how we remember that one. And then the last couple have to do with pH and pOH. So the key thing here is this is a logarithmic scale, and when we look at the hydrogen ion concentration, it is going to be 1 times 10 to the minus pH. So basically the pH represents the exponent right here. So if you go from something that has a pH of 7 versus a pH of 6, this one is going to have 10 times more hydrogen ions. So that's what that logarithmic scale means. There's also something called pOH, and the relationship between pH and pOH is this: pH plus pOH equals 14. So the first couple problems actually relate to that, pH and pOH. So let's try this. So problem A, we can see we're given the hydrogen ion concentration. And remember we set up here, the pH represents the exponent right there. So the exponent here is 10 to the negative fifth, so the pH is 5. So notice how it's 10 to the negative pH. So anyways, basically leave off the negative number there. And since pH plus pOH equals 14, well, what's 14 minus 5? That is 9. And then to determine if it's an acid, base, or neutral, I'm going to look over here at my pH value. So we know if the pH is less than 7, then it is an acid. All right, this one right here, it's not written in scientific notation. Sometimes it can be helpful to write that out. So let's see. We can move this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, that got a little messy there. It looks like this is 1 times 10 to the negative ninth, which means our pH is going to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just want to make sure I counted that right. The pOH is 14 minus 9, so that is 5. And since the pH is 9, this one is a base. All right, this one gives us the OH concentration. So the exponent in the OH concentration will tell us the pOH. So if the OH is 1 times 10 negative 4, the pOH is 4. And then we know pH plus pOH is 14, so my pH must be 10. Since my pH is above 7, this thing is also a base. All right, down here, again, this one's not in scientific notation, so we might want to write it out that way. This is 1 times 10 to the negative 2. So my pOH is 2. That means my pH is 12. And again, this thing is a base. All right, so let's look down at this next one. Determine the H and OH. So this time we're working on our way backwards. So instead of being given the concentration and finding pH, we're given the pH and trying to find the concentration. So we know that the hydrogen concentration is 1 times 10 to the negative pH. Again, I'm using this equation right here. Okay. I also know that pH plus pOH is 14. So if my pH is 4, my pOH must be 10. And this is going to be 1 times 10 to the negative 10. So I should write out this relationship as well. So just like the H is 1 times 10 to the negative pH, the OH minus concentration is 1 times 10 to the minus pOH. And these are both, so they're logarithmic scales because the pH and the pOH represent the exponent here. Okay, so when you're trying to figure out if something is an acid, base, or neutral, you're just going to look at the pH. Here the pH is less than 7, so it's an acid. All right, if the pH is 7, that means the H plus is 1 times 10 to the negative 7. The pOH must also be 7 because pH plus pOH out to 14. So that means my OH is also 1 times 10 to the negative 7. And if the pH is 7, this is neutral. And you can see when things are neutral, they have equal amounts of H and OH minus. Okay, so if the POH is 3, then that means my OH is 1 times 10 to the negative 3. And that means my pH is 11. So I'm going to run out of room here. So this is 1 times 10 to the negative 11. And if my pH here is high, it's greater than 7, that means this thing is a base. All right, here, what if the POH is 10? That means this is 1 times 10 to the negative 10. pH plus POH is 14. And here's this equation. So my pH is going to be 4. And then this is 1 times 10 to the negative 4th. So since the pH is less than 7, this is an acid. And one thing I'll say on the quiz, you will be given these equations here. I'll write this here. You will be given these 3 equations. So don't worry about memorizing them. You just need to know how to apply them. Okay, so list properties of acids and bases. This is something where you can look back to the reading in 633. You could look back at the notes, which I think were on page 15, but some things you can say about acids. You could talk about what color they change indicator. So you could say they turn universal indicator red. You could say they have a pH less than 7. You could say they're corrosive. That's something that could be said of both acids and bases. So you're looking for properties like that for your acids or bases. You could say acids taste sour. You could say your bases taste bitter. They turn universal. Maybe like, blue, purple. The pH is greater than 7. They're also corrosive. So those are the types of things we're looking for there. Okay, so down here, we're going to practice writing out these Bronsted-Lowry equations. And our definition here, let me see if I can get a smaller size of pen. We're going to use this definition that BAAD, that bases accept and acids donate. And what are they accepting or donating? These hydrogen ions. So NH3 is a base. So when you put it with water, it is going to be an H acceptor or a taker. Okay, so NH3 is going to turn into NH4. Why? Because it just took a hydrogen. And with that hydrogen moves a positive charge. H2O becomes just HO, which we usually write as OH. And it lost a positive, so now it's negative. All right, let's look at this one, H2S. It is an acid. Acids are going to be hydrogen givers. Okay, so if H2S gives away a hydrogen, now it's just going to be HS. It's going to have a negative charge because it gave away something positive. H2O becomes H3O because it gained a hydrogen, and it also gains a positive charge. So let's look over here at this one, SO4 2-, it is a base. So that means it is going to be an H taker. So SO4 goes from having no hydrogens to 1 hydrogen. And if you look at its charge here, it went from -2 and then it gained a hydrogen, so now it's going to be -1. So it's going to have a negative charge. H2O started out as 0 and it lost something positive, so it's going to have a negative charge as well. So you're left with OH minus. So this, sorry, that got messy. This is my reaction here. The other thing you should notice is the charge on the left equals a charge on the right. So I've got -2 charge on the left and I've got 2 negative charges on the right. All right, this one, HNO2, it's an acid. So when you put it in water, it is going to be a hydrogen giver. So HNO2 becomes just NO2. And H2O becomes H3O. Since we're moving a charge, NO2 becomes negative, H3O becomes positive. So that's how you write out those reactions. So notice here we tell you which things are acids or bases. You also want to be able to spot acids or bases based on their chemical formula. And we'll do this for the more obvious cases. So what we want to keep in mind here is that acids tend to add hydrogen to the water and bases add hydroxide to the water. So if you notice up here in these reactions, right, because acids are hydrogen givers, and then bases are hydrogen takers. When they take a hydrogen, you end up generating hydroxides. So that's what our acids and bases do. And so if you look here at this chemical formula, it looks like MgOH2 has hydroxides in it. So this is going to be a base because when you stick MgOH2 in water, it's going to make magnesium ions and hydroxide ions. So anything that makes hydroxide ions is going to be a base. If you look over here, this is going to be an acid, which I can tell because it is it starts with a hydrogen. So acids tend to begin with an H plus in their formula. When you put it in water, it's going to make H plus ions. So then we predicted products and equations. We also want to be able to look at an equation, identify who's an acid and base. So if you look here at this equation 6, it looks like HNO2 gives a hydrogen to water, becoming NO3 minus. So since this is the hydrogen giver, it is the acid, and water is the hydrogen taker, it is the base. And then down here, it looks like ClO minus takes a hydrogen from water to make HClO. So if it's a hydrogen taker, it's a base, and water is a hydrogen giver, so it's an acid. Notice water can be an acid or a base, depending on who it's paired with. And then last problem with 7, we're looking at the difference between a strong acid and a weak acid. Strong acid, 100% splits into ions. And then the weak acid mainly stays as a molecule. So for example, HCl is a strong acid, HF is a weak acid. If I had 4 molecules of HCl in a solution, all 4 of them would split up into H plus and Cl minus ions. So I might just draw 3 because I'm running out of room. Okay. If I had HF and I had 3 molecules of HF, most of them would just stay as HF, but maybe like one of the 3 would separate out. So notice when you have the same concentration, right, we have the same number of molecules in the same volume, my strong acid is going to make more hydrogens. So this was going to have a lower pH for the same molarity versus a weak acid, because weak acids are going to make less H pluses. All right, so that's it for the review. Thanks.